my dear students. Welcome back, 9th class. Today I'll continue with that first chapter. I have given one video in my previous chapter, that is matter in our surrounding. Today I'll continue with that, right? So in my previous video I have covered solid, liquid and gas, what actually the matter is and the properties of matter. Today I'll continue with the conversion of the change of state, latent heat and temperature and the measurement. Clear? Shall I start? Now, how the conversion of change of state takes place. Like if I say liquid is changing into gaseous state, solid is changing into, yes, liquid state on heating. And if I cool, the vice versa. That is, gaseous on cooling converts into liquid, liquid on cooling changes to solid. How it happens? Suppose in kitchen, you want to make tea. You put in a saucepan, that is 4 cups of water you took, and you switch on the knob of the gas. After some time you will see that water starts boiling. Am I right? Yes. So water starts boiling and you put tea leaves or milk and all. Then how it happens? How the water starts boiling and you can see the vapors are coming out. How it happens? What is the inside story of that the temperature you are providing by the gas and how that liquid gets converted into gas? Very, very important, student. If you have come to know about this inner story, the rest of the chapter will be easier for you. All are related to it only. Okay, so I am going to explain you about how the change of state of matter will take place. Now, in this diagram, this is the burner, spirit lamp and the called burner. Now, this I have taken one beaker on some stand is there. Now, beaker, and I am providing temperature. This is the thermometer to measure the temperature of the water. Now, that means this is the water vapor which is releasing out. How it is happening? This I asked you. What is the inside story going on? Start. Now what happens when I am providing the temperature? Initially what happens? Listen very carefully. When the temperature is provided to the liquid particles starts vibrating first. Initially it was still. As soon as the temperature is provided, the particles of the liquid, I told you in that the particles are continuously moving. But here what happens and faster when the heat is provided. Clear? So here when I am providing temperature, the liquid particles will start vibrating on their own position. Then next step, they start colliding with each other. This is how the particles collide with each other. Collides with each other. First they vibrate, first step. On providing temperature to the liquid particles will start vibrating and then they collide with each other. Collides. Second step, during collision of the particles, what happens when the collision starts? Suppose if I say collision, I am colliding these particles. After some time you will feel some warmthness. So here when the particles are colliding, they gain kinetic energy. Kinetic energy means particles starts moving. Kinetic movement. So when they collide with each other, the more and more particles starts or gains kinetic energy and they move much faster. And because of this more kinetic energy, the more amount of heat energy is produced. More faster, more amount of heat energy produced. Right? So more amount of heat energy is produced and this temperature produces the high temperature. This heat energy, what it does? This heat energy will overcome what? The force of attraction between the liquid particles. Overcome means the liquid particles attracted to each other. This kinetic energy will allow those particles to overcome this force of attraction and what? Overcomes the force of attraction between the liquid particles and finally what happens? These particles will leave their fixed position and get converted into gas. Very, very important. First step, providing temperature to the liquid. Particles starts vibrating. Then they starts colliding with each other. Then what happens? Due to the collision, they gain kinetic energy, and due to more amount of kinetic energy, particles move much faster and more amount of heat energy is produced. And that heat energy will overcome this force of attraction between the liquid particles. And due to the heat which is overcoming, the particles will leave their fixed position finally and get converted into gaseous state. These are the steps. This is how the liquid gets converted into gaseous state. Clear? And the same procedure for the solid also. If I take solid instead of liquid, the same thing will happen in that. It will take time. And the very important thing, when I measure the temperature at this state, it will remain same. When it is getting converted into vapor, that time if I measure the temperature, the initial and the final temperature which we are measuring will remain same. Now question arises, why the temperature remains same? Because we are continuously providing heat. It has to be risen? No. Why? Then where that heat energy goes? That heat energy is used up in conversion of the state of matter. That heat energy is used up here. That is, I told you the inside story. It is used up in conversion of state. And that heat which can't be seen is known as latent heat. So what is latent heat? It is the hidden amount of heat which is used up in conversion of state. That is called latent heat. Latent heat are of two types, latent heat of vaporization and latent heat of fusion. Then what is latent heat of vaporization? It is the amount of heat energy required to convert 1 liter of liquid. Standard I am taking 1 liter. Right? So what is latent heat of vaporization? It is the amount of heat energy required to convert 1 liter of liquid into gas at atmospheric pressure at its boiling point. I will not use melting because here the boiling is going on and atmospheric pressure should be there. There is atmosphere, so pressure is there from the atmosphere. By that time only this work is going on. Clear? I am repeating again, what is latent heat of vaporization? It is the amount of heat energy required to convert 1 liter of liquid into gaseous state at atmospheric pressure at its boiling point. This is known as latent heat of vaporization. Now, that means steam. Here, water is converting into steam. Steam, what happens? Burn, severe burn. The question is there in your NCERT. Why the steam shows severe burning than that of boiling water? Because steam gains more amount of energy than that of the boiling water. That is why gains more amount of heat energy than that of the boiling water. This is due to latent heat of vaporization. That is why what? Steam burns with more severe burns. Clear? So this is how. Next is latent heat of fusion. Fusion, what is that? It is the amount of heat energy required to convert the 1 kg of solid into liquid at atmospheric pressure at its melting point. Melting, fusion. Melting is going on. Solid is melting. Clear? So what happens? Latent heat of fusion when 1 kg of solid is converting into what? Liquid. The amount of heat energy required. Again the question, why at 0 degree or 273 degree? The ice is more cooling effect. Ice is more effective in cooling than that of water. Because ice gains more energy, more amount of heat of energy and latent heat of fusion due to latent heat of fusion. Ice absorbs more amount of heat energy. That is why ice shows more effective in cooling than that of cold water. Clear? Now this is how latent heat. Now next is temperature. What is temperature? It is the degree of hotness or coldness of the body. Clear? So temperature, measurement of temperature are using two scales are there in your book. The third is Fahrenheit is also there, but it is not there. Celsius scale and Kelvin scale. What is Celsius? It is degree Celsius, and Kelvin, after the symbol of the Kelvin is K. These are the units to measure the temperature. If I want to convert degree Celsius to Kelvin, then we will add 273. Actually, it is 273.16, but in your syllabus, you are quite young. So, we will use 273 will do. So, when degree Celsius to Kelvin, we will add 273. When Kelvin to degree Celsius, we will subtract 273. You will get the answer. Suppose 6 degrees Celsius. 6 plus 273, the answer is there in Kelvin. Clear? So, this is how the chapter latent heat, conversion, these are all very important point. In my next video, I'll give you what actually the sublimation is and evaporation, and so many examples related to evaporation and what are the factors which is affecting evaporation. Clear, students? Any of the doubt, please write it in my comment section. Definitely I'll answer you all. Right? Thank you so much, students. Don't forget to subscribe 9th class. Thank you. Thank you so much.